of the form x to the n equals k by using the nth root. And we have to be careful here. If n, the exponent, is even, there will be multiple solutions to the equation. So the first example is x squared equals 25. And we can just by sort of trial and error see that there are going to be two solutions to this equation. For example, note that 5 squared is 25, and also note that negative 5 squared is 25. Now, the process that we would use to solve the equation would be, if x squared equals 25, then x is the positive or negative square root of 25. Since the square root of 25 is 5, we say that x is positive or negative 5. Now, sometimes we want to write this as a solution set. So the set containing negative 5 and positive 5. Now, notice in the second example, when we're asked to solve x cubed equals 8, there is no way to have two solutions like we had in the previous one. Because notice that 2 cubed is 8, but negative 2 cubed is negative 8. Since we only want x cubed to be 8, we would not have two solutions. So now if x cubed equals 8, what we would say is x is simply the cube root of 8. The cube root of 8 is 2, and so then x is equal to 2. Or we can write the solution set containing 2. So now let's complicate things a little bit. What if we had a quantity, x plus 3 squared, and that's giving 64? We can use the same premise. Before we had, say, x squared equals a number. Well, now we just have this quantity square. Well, what we'll say is, if we have a quantity squared equal to 64, then the quantity, x plus 3, must be the positive or negative square root of 64. And so then x plus 3 must be equal to positive or negative 8. Well, we don't want to know what x plus 3 is. We want to know what x is. So then what we do is we split it up into two pieces. So that x plus 3 would equal negative 8, or x plus 3 would equal positive 8. Subtracting 3 from both sides on either equation, x would equal negative 11, or x would equal 5. And so we could write a solution set containing negative 11 and 5. If we had x minus 4 cubed equal to 125, again using a similar premise, we could write that x minus 4 is equal to the cube root of 125. Notice again, I did not write positive or negative since it was a cube root. The cube root of 125 is 5, so we have x minus 4 is equal to 5, and adding 4 to both sides, we have x equals 9. And so we have a solution set containing 9. Let's complicate the situation a little further. Now we have 3 times the quantity x minus 9 squared is equal to 48. Well, I can bring this back to the previous example, basically, by dividing both sides by 3. So now I have x minus 9 squared is equal to 16. Using square root, I have x minus 9 is equal to the positive or negative square root of 16. And the square root of 16 is 4, so I have x minus 9 is equal to positive or negative 4. So again, now splitting this up into two pieces, I have x minus 9 is equal to negative 4, or x minus 9 is equal to positive 4. Adding 9 to both sides on either equation, yields x is equal to 5, or x is equal to 13. And so I'd have a solution set containing 5 and 13. Again, now let's look at an example involving a cube. 2 times the quantity x plus 6 cubed is equal to 54. Dividing by 2 yields x plus 6 cubed is equal to 27. Applying the cube root, I would have x plus 6 is equal to the cube root of 27. The cube root of 27 is 3, so I have x plus 6 equals 3. And finally, subtracting 6 from both sides, x would equal negative 3. And our solution set would only contain one value, negative 3. Alright, finally, let's complicate the situation just a little further. 5 by the quantity x minus 3 squared minus 9 is equal to 66. The first thing that I would do is add 9 to both sides. This gets it back to an easier exercise. I'm also going to kind of move over to the left for space reasons. So I now have 5 by the quantity x minus 3 squared is now equal to 75. Now this is like the previous exercises. I will divide by 5. So x minus 3 squared is 25. Now applying the square root, I have x minus 3 is equal to positive or negative square root of 25. The square root of 25 is 5, so x minus 3 is equal to positive or negative 5. Splitting it up into two pieces, x minus 3 is equal to negative 5, or x minus 3 is equal to positive 5. Adding 3 to both sides on either equation, x is equal to negative 2, or x is equal to 8. Alright, in the last example, let's solve the equation 3 by the quantity x plus 4 squared minus 12 is equal to 84. Following the example, the previous example, I'll add 12 to both sides to begin with. So now I would have 3 by the quantity x plus 4 squared is equal to 96. Dividing by 3, I have x plus 4 squared is equal to 32. Using square root, I have x plus 4 is the positive or negative square root of 32. Now this one's a little bit different because 32 is not a perfect square. But recall that we can still simplify the square root of 32. Because the square root of 32 is the same as the square root of 16 times 2. And breaking up that square root as the square root of 16 by the square root of 2, that's 4 times the square root of 2. So I now have that x plus 4 is equal to the positive or negative 4 by the square root of 2. So, again, breaking it up into two equations, x plus 4 is equal to the negative 4 times the square root of 2, or x plus 4 is equal to positive 4 times the square root of 2. Subtracting 4 from both sides of the equation, on either equation, I would have x equals negative 4 minus 4 times the square root of 2, or x equals negative 4 plus 4 times the square root of 2. And I can write the solution set, negative 4 minus 4 times the square root of 2, negative 4 plus 4 times the square root of 2.